One of the things that our modern computer age allows us to do is to generate tons of data. And it becomes a problem to understand what's going on with a set of data, especially if your data set is pretty big. So right here is some data that I picked up from the National Oceanic and Atmospheric Administration. It's a pretty cool data set, and it's actually already been kind of squeezed down considerably. But it's average temperature by decade for all 82 counties in Michigan, going back to the 1890s. So it's pretty cool. And we'll play around with this later in the semester. But for now, you just kind of scroll through and realize that, gee, if you had to look at this and make sense of it all, boy, it'd be really difficult to do just by looking at this. You can't. You need to start summarizing things. You need to collect them and try and find out what's typical and what's not typical. So that process in statistics is a branch of statistics called descriptive statistics. And we're going to do some descriptive statistics, starting out with frequency distributions, finding out, well, where is your data? Where are the numbers? So to begin with, we're going to work with problem number 18, which is in your book. Analysis of the last digits of weight. So right here. Weights of respondents were recorded as part of a California interview survey. The last digits of weights from 50 randomly selected respondents are listed below. Construct a frequency distribution with 10 classes. Based on the distribution, do weights appear to be reported or actually measured? What do you know about the accuracy of the results? So we're going to do this one kind of sort of by hand. And I mean kind of sort of this way. If you were stuck doing this and you didn't have any technology available, what you'd have to do is create yourself a little frequency distribution this way. So this is problem number 18. Let's draw ourselves a little bar. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we've got all the different possible digits, 0 through 9. And then you just go through and tick things off. Do little hash marks. So I've got a 5, I got a 0, a 1, a 0, etc. And I don't know, do I need to do that by hand to convince you that it'd be really, really boring and dull to do it by hand? I'm hoping not. Here's what it would look like if you actually completed that task, did it all by hand. As you get something like this. And let's just go to the summary. The executive summary is this. You'd have 26 people whose weight ended in a 0. One of them that ended in a 1. One that ended in a 2. 2 that ended in a 3. 2 that ended in a 4. 12 that ended in a 5. 1 that ended in a 6. None that ended in a 7. 4 in an 8. And 1 in a 9. So there's your frequency. So, okay, that's nice. Leave some room here because we're going to come back and work with this later as we go through sections 8.2 and 8.3. But for now, this is your distribution. This shows you where your data is, and it's a nice summary. Now, is there one thing that jumps out about this data set here? That's just the digit, so the trailing digit. Is there something that jumps out about this data, about the frequency of the data? So 0. 0 is the most frequent. Okay, what other value is pretty frequent? 5. What do you think that's saying about the data set? Do you think people are actually being weighed or you're just asking somebody, well, how much do you weigh? And they're going, I don't know, 170, 180. What do you think is the case in this one? Yeah, they're just asking people. And people are taking, a good guess. And it looks like they're rounding one way or another. I mean, in this case, it looks like they're rounding pretty generously to the nearest 10 pounds, right? All right. So that's a quick way to lose 10 pounds. Oh, yeah, 180, sure. So nice. But that's the point here, is that by summarizing this, you can see something in the data that is not quite as apparent by looking at the raw data itself. So that's good. That's really nice. Now we're going to try and refine our work and our knowledge of frequency tables here and working with some other problems. So let's move down to problem number 6 here. And I'm going to repeat that data set for us here. It's the data set at which actors, or reflects how old an actor was when they won the Academy Award for Best Actor. So we have ages of 20 to 29, 30 to 39, 40 to 49, and so on, up to 70 to 79. And we have the frequencies as well. So the frequencies would be 1, 28, 36, 15, 6, and 1. So like I said, there's some things that I want you to know about frequency distribution like this. These are your classes here, and each class has an upper class and lower class limit. So lower class limit and upper class limit. And within each class, you're going to have a class width. So let's do that here, class width. Now certainly you can be forgiven for thinking that the class width, how wide this class is 9. That's not the actual class width. Class width is the distance between two adjacent lower class or upper class limits. So the class width here, for instance, you could do it as 30 minus 20 equals 10. The class width is 10. That's how wide your particular classes are. Now, I'm not really comfortable or fond of this, but let's go on to the class midpoints. Class midpoints. If you had to represent each class with just one number, you'd probably pick the midpoint. And what's in the middle of this is the average of these two. So 20 plus 29 divided by 2, 49 divided by 2 is 24.5. What do you suppose the next one is? What's the next class midpoint? Yeah, 34.5. Thank you. 34.5, and so on. 44.5, 54.5, 64.5, yeah, and 74.5. Those are your class midpoints. If you were to plot things, if you were to do what's called a frequency polygon, then you could use these as your x values and these as your y values. Okay, let's add one last thing to this, and that is the class boundary. Class boundary. So the class boundary is what really separates your data. It's like, okay, here's the cutoff, and that's it. Now the author gives it to us in this particular case. Class boundary is right here. It's between 29 and 30, so 29.5. Now that'll work a little bit different on Excel and Google Sheets. We'll see what the class boundaries are there. But 29.5, what do you suppose the next one is? Yeah, 39.5, and so on. So those are your class boundaries. That's what really separates it. So if you were 29.4 years old, you should go into this class. But if you're 29.6 years old, you get rounded up into the 30s. So that's what this is saying, is that it tells you, all right, where are you going to fall in these classes. Yes, please. It'd be like the next class. You know, I don't really necessarily need this one. Hopefully you don't. In fact, we don't have any data beyond this, but it would be the next one if you thought about 80 to 89. So, and it is a limit here. Anything beyond 79.5 should not be in this class. Otherwise, you should relabel it, maybe 70 and up, in which case you wouldn't have this as a class boundary. That's a good question, and you'll see that a little bit when we do our work with Google Sheets coming up next. Okay, so let's see about getting Google to do this or Excel to do this for us, because this kind of work, and I did it in my morning class, and I pity them and I thank them for doing it, but doing this stuff by hand is just no fun, and that's why we're using technology. So let's open up Google Sheets or Excel, whatever you've got, and work there. So Google Sheets, there we go. Now hopefully you have this data opened up, and the first data set we're going to come to is data set for problem number 11, the duration of eruptions for Old Faithful. So all of those you with laptops today, were you able to get that open in one fashion or another and into a spreadsheet? Okay. All right, that's good. So it should have opened up pretty much like what I have here, right? Now, what I want to teach you is how to get a spreadsheet to do this work for you, because it's kind of a pain. Now, I've already pre-labeled these for you in accordance with the problem. The problem itself, problem number 11. Let's take a look at that here. There you go. So we've got all the data here, and there's the description of the problem. They want you to use a class width of 25 seconds and begin with a lower class limit of 125 seconds. So that's the lowest class that we want. We want to move up from there in increments of 125 seconds. So, okay, let's see about doing that. Now, to do this on a spreadsheet, what you're going to need to do is set up these maximums, so your class boundaries. Now, in Excel, these are typically called bins. So you're going to need to set these numbers up. The problem said we wanted to start at 125 and work up in groups of 25 from there. So that's what I've got. So that means anything 125 or less is going to go here. If I did 125.1, it's going to go in the next group, and so on. So here's my class classes. The last one I left open. Notice the last one. This is kind of going to what you said. Remember I did 79.5? If I put one here, then this wouldn't be 250 and up anymore. It'd be 250 to 275. So that would change things. By not putting a number here, I'm leaving it open and saying, all right, this is the catch-all. It's everything beyond 250. So it was a good question you had just a minute ago. Let's do our frequency here. In order to do any commands on a spreadsheet, you need to start by typing equals. And if you start typing frequency, just like everything nowadays, the computer's going to try and guess what you mean. It's going to autofill it. So let's just press enter here. There's two things you're going to need to tell it. One is where the data is. Now help us out here. The data is in A2, which is here, first row, or first column, second row, colon, all the way down to A51. So that's where our data is. You can see that your spreadsheet is grabbing all that data. And then you have to tell it the bins. So let's do a comma. And now we're going to have to list these cells here where the bins are. Now you got two choices. You can type it in like I just did now, or you can click and drag. So let's click and drag. You click and drag. So you should have cells D4 to D9. So I'll pause a second, give you a chance to make sure you're up to speed here, because I don't want anyone to fall behind. So frequency, you should have A2 colon A51, comma, and then our bins, which is D4 to D9. Charbel? Okay? Doing all right? Yes, sir.
I can't seem to highlight it. It just like stopped. It's not like up different colors how you had it there.
Did you have a comma after A51? Okay. I'm not sure why it's doing that, unless you're trying to edit this at the same time I'm editing it. Did you copy your data?
Yeah, that was my problem.
Okay. You copied it into a different spreadsheet. Why don't you just try typing in the numbers D4 colon D9? Because I'm not sure exactly what's going on with that. It should give you what we've got here. When you're ready, press enter, and it should populate this column here in the middle with all your frequencies. Didn't work? Let me take a quick look at that. There. All right, so all right. So our pause button here. Oh, you don't want T9 equals frequency. All right, so let's clear it out. Equals frequency. So we had something before the equal sign. I don't know how or why they got Let's go back here. So it's nice. Now, I promised that we'd play around with something and look at something that was pertaining to your question earlier. What if I change this to 125.1? Watch what happens to the frequency. So enter. What happened? It jumped up to the next category, right? So this is the absolute maximum. That's your class boundary for this one. So it works a little bit different than what Mario Triola wants, or what's said of our age of actors. That's okay. This is the absolute maximum for anything in this class. So this is anything up to and including 125. So if I turn this back to 124.9, I should see this jump back from this class into this class. There you go. So that's the understanding you should have of these class, or these bins, is that they're a class boundary. Okay. All right. So are we okay with the class boundaries here? All right. Let's take a look at the actual data set. What do you notice about the data set? There's two observations that we can notice here based on our frequency distribution. What two things are you seeing from the data? Nothing? What are you seeing from the data? There's two observations you can make based on the data. Two observations you can make based on the data. Let's start with the easy one. And I don't think either of them is that hard. Typically speaking, when you're watching Old Faithful, how long are the eruptions going to last? About. Yeah, longer than 200 seconds. Good. So if you had to tell somebody, what to expect, you'd say, all right, probably around here, right? 225 to 249 seconds. So about 4 minutes, right? Because 60 seconds in a minute, 240 seconds, 4 minutes. So about 4 minutes is what you should expect if you spend a little time waiting for Old Faithful. So that's one observation you can make. Now, is there somebody who showed up to watch Old Faithful that got kind of cheated? Yes? No? Do you see it? What happened to somebody? 125. They only got 2 minutes, man. That's nothing. They got half of what they should have got. Give me my money back. So this is what's called an outlier, but it's made particularly clear when you're looking at the frequency distribution, right? You can compare it to other things pretty nice because, wow, I mean, most of them are well up here. All right, I mean, you've got 50 observations and only one of them is way down here. So it's nice that you can see, relatively speaking, where things are at. So those are our two conclusions from this data set. Let's go back to our frequencies. And we're going to do a little bit more with problem number 18. Are we okay with problem number 11 here? You okay with those? Charbel? Yes. Really? I'm not sure what's happening there. I'd have to look at it. One possibility is that maybe somehow or another you got an edited version. I'm not sure, but I have to look at it. One good thing though that I do promise you is that on exams, you're not going to have to input data. I will have the data already input for you, so you can rely on having clean data not having to worry about copying things in. That's something I really didn't like about using the graphing calculator is when people did problems on the graphing calculator, very easy to make a typo in entering data. You will not have to worry about that. All right. But in general, even though it might not match exactly, are you generally getting similar results? Okay. Yeah. Hard to say exactly what's going on there, but as long as you're getting the idea, that's good. Now, for your convenience, I put in this document some things you should be getting out of this example and a little bit of the how-tos here. So how to create a frequency distribution, we just did that. And then in the next section, we're going to learn how to create a frequency histogram. Basically, this is going to be a visual presentation of the data that we created with our frequency distribution. All right, to wrap things up from this section, let's go back to problem number 18 and do a little bit more work with that. So one thing you could do is look at frequencies. So we have the frequency of our last digit. But instead of looking at the frequency, we could also look at something called the cumulative frequency. So let's figure out what that is. So cumulative frequency. Frequency. And what the cumulative frequency is going to do is kind of accumulate a total. It's going to be a running total as you move along. So first one is just going to be 26. But the second one was how many people had a trailing digit of a 1 or less. And it'd be 27. And then 28. What would the next one down be? 30. Thank you. 32. 44. 45. 45 again. 49. And finally 50. So by the time you get down to here, that's everything. Everything has to have a trailing digit of 9 or less. Now the other convenient thing about this is that it tells me how many observations I have in this data set. There's 50 observations. If somebody else had a different data set and you wanted to compare them, it might be difficult to compare because they have a different number of pieces of data. But one way you can compare it on kind of a more even up basis is to look at the relative frequency. That is, what percentage of people in this data set had a trailing digit of a 0? Well, 26 divided by 50 is 0.52. 1 divided by 50 is 0.02. So this next column is going to be the relative frequency. And so on. So I've got another 0.2, and then a 0.04, and then a 0.04 again, 0.24, 0.02, still 0, 0.08, and 0.02. Now, in absence of any rounding errors, what should this total be? 1. Because it's 100%. Now sometimes if you want, you can write these as percentages as opposed to decimals. That's fine. That'd be 52%, 2%, and so on. But it just gives you another way to look at your data. And it's particularly helpful if you want to compare different size data sets. So that would be your relative frequency for that last column. Is it clear how to get those? You're just going to take each frequency and divide by n. So nothing too dramatic there. Okay. Any questions or comments on frequency distributions? We okay with that? Eventually you're going to get an assignment in Google Sheets that I'm going to ask you to do. So hopefully you're comfortable with that or can get comfortable. If you have some questions, please come see me. Be glad to help out. For homework, try 1 through 19. And that's section 2.1. That's the 13th edition, yeah.